it into two. She is supposed to take Igneous and I'm supposed to take Metamorphic. She is supposed to start the class. And when she finished before I start, because Igneous comes before Metamorphic. We all know how Metamorphic rock forms. You're supposed to have a very good understanding of Igneous rocks before we even go to Metamorphic. But as it is, has she taken you any class?
No, ma'am.
So you've not done anything with her?
No, ma'am.
All right. The good thing is I brought some introductions from Igneous for you to so that you can follow up. But she's supposed to have finished completely. I thought she was teaching you. Your class rep didn't reach out to her. It didn't reach out to me. We are the one that had to reach out to you people this January. And it's not like that. If you don't hear anything from your lecturers, you follow up. If I knew she has not started, I would have told her to start or would have done something about it. But you people kept quiet until January. So what we're going to do now, we're going to run the course concurrently. She will be teaching her part, I'll be teaching my part. Because if I'm going to wait for her to finish before I start, you may not finish this course, or we will end up doing everything, doing a crash program, and then you end up failing. And I don't like that. I like giving my students time to understand, to read, to follow. I don't want to teach everything within 2-3 weeks. Okay? So she's going to be teaching you. Your class rep has fixed Monday for her, and he fixed Friday for me. I'm so sorry today, my laptop messed up, but we can pick up from where we stopped. So how many people do we have in the class now? Still 19. All right, so let me have attendance, please. Okay? I normally don't take attendance, but in cases like this, I take attendance because I give marks. I can give you an extra mark if I notice you didn't do well in exam. You just being in the class, I can give you an extra mark. So please put down your names and your matric number. So can I start or we should wait a bit?
Ma, please start, ma.
All right, thank you very much. Okay, we all know what the rock cycle is, right? Do we know the rock cycle? Do we understand the rock cycle?
Yes, ma'am.
All right, you understand the rock cycle. It is just a web of processes, right, that outline how each of the three major rock types, the three major rock types are the igneous rock, the metamorphic rock, the sedimentary rock. This cycle just outline how they formed, okay, their breakdown, and the different processes that forms them. That is just what the rock cycle is, okay? Example, you have the sedimentary rocks. Mostly you have shale, all right? We can turn to, it can break down, turn to shale, turn to slate, we are going to find out the metamorphic process later of how sedimentary rocks change to metamorphic rock. You're going to have very good understanding of that before the end of the class. So what this cycle is just explaining is how each rock type formed, how the igneous rocks formed from molten magma, okay? And the cycle continues, okay? So in describing an igneous rock, the best and most convenient way to start it is from the magma, which is the igneous rock section of the three types, okay? So the magma is a hot rock. It is extremely hot to the point that it is molten. So molten rock is just like you carrying a plastic and putting it in fire. It can melt. Metal, if you put it in fire, despite the fact that it's a solid, it will melt at a point. When the temperature reaches its temperature of melting, it will melt. So magma are rocks that have undergone extreme temperature and they have become molten. They are not pure liquid. Even though some of them are liquid, but we call it molten state because it's in a kind of crystallizing state, but it has not fully crystallized. Do you understand? So generally what happens is that this process generally starts around 800 degrees Celsius or about 1000 degrees Celsius, which you're going to see later, depending on the composition of the pressure. If the pressure is high, very high, melting can start at even 800 degrees Celsius. But if the pressure is a little bit low and then temperature is high, it can start at 1300 degrees or thereabout. So the pressure and the temperature work hand in hand in determining how quickly the rock melts. Okay, are we following?
Yes, ma'am.
So magma can either cool slowly within the earth crust, which is what Prof is going to be teaching you. This slow cooling occur over centuries or millions of years because it takes a very long time for them to cool and form rocks. So what generally happens is that this magma will form either intrusive igneous rocks or extrusive igneous rocks. Intrusive is that it formed at depth. When it is extrusive, it formed at the surface, and they all have different characteristics. The characteristics of the intrusive rock is totally different from the characteristics of the extrusive rocks. Do we understand? Prof is going to take her time to explain all that for you. So from the magma, you have the intrusive and the extrusive. Let me see if I can get a highlighter, a laser pen. Good. So I have it here. You see the red pen, the red marker. You see the intrusive here? That's from magma. Remember, I said the most convenient way to explain this rock cycle is starting from the magma. So if you are asked to explain the rock cycle, if you're confused, start from magma. Is the easiest. It makes it flow for you. So you have magma cooling down to form either intrusive rocks. When it's formed beneath the earth surface, you can see the earth surface, this ash colored line cutting across this cycle. So it's either it forms intrusive rock forming beneath the earth surface or extrusive rock above the earth's surface. Do you understand? So these igneous rocks can undergo breaking down or weathering. The first thing that happens is that when they occur as intrusive within the earth, they become uplifted due to tectonic activities, which pushes them to the surface. Extrusive is already on the surface. It does not need this process. But intrusive rock that was buried at depth can be pushed out up to the surface due to uplift, which we now find them as outcrop. You're going to start your field work. You're going to see a lot of outcrops when we go to the field. Outcrops are exposures of rocks that formed billions of years ago. They are where intrusive rock, formerly intrusive rocks, pushed to the surface, either due to tectonic activity or due to erosion. Most of the time, like the ones in Nigeria, were pushed to the earth surface due to erosion. Erosion is that the covering, the material covering is that formed intrusive has been removed. Okay? So that what you have now is outcrops. So these outcrops that you have on the surface of the earth, because they are exposed to weather, to high temperature, to sun, to water, to wind, what happens? You start having abrasion, you start having weathering, and you start having the general breakdown of these rocks due to environmental factors. Okay, so you now have these rocks being broken down into smaller particles. Most all the sand we have right now were rocks that were broken down from, were materials that were broken down from rocks. Do you understand? So you now have them broken down to form sediment. The sand you see on the surface or when you're walking, they are sediments. But when these sediments or the plastic material that were broken down from igneous rocks, when they become buried, they become compacted due to heavy load. You know, during burial, it's just like when you're piling boxes upon boxes on top of each other. At a point, the box beneath, the one at the bottom, will begin to deform because of the pressure from the one above. So it is the same thing that happened to this sediment. When they are buried, there is compaction, there is cementation, there is diagenesis, high temperature. So many things happen to this sediment whereby they become compacted due to pressure. The one beneath, just like the boxes, the one above would crush it down. It becomes compacted and it will form sedimentary rocks. So these sedimentary rocks, due to deep burial and deep high temperature, can be changed to metamorphic rock. We are going to be seeing those processes, how sedimentary rock form metamorphic rock and how igneous rock form metamorphic rock. So now we are back, we've left sedimentary section, we are back at metamorphic rock now. So these sediments can undergo deep burial under high temperature and pressure to form metamorphic rock. The same thing with the igneous rocks. Both intrusive and extrusive igneous rock can undergo high and deep burial and high temperature and pressure, in which they can form metamorphic rocks. This metamorphic rock now, as you notice, igneous and metamorphic, igneous rock form metamorphic, sedimentary rock form metamorphic. When metamorphic rocks start undergoing very high temperature, above that 1,300 degrees Celsius I just described, what happens? It starts melting to form molten magma. Okay? And when we get back to this molten magma, the process starts again because it forms igneous rocks and the process starts again. So this is rock cycle. How rocks form, the magma form three different rock types. It starts, begin from the magma, you have your sedimentary rock, you have your metamorphic rock. Begin from the magma, you have your igneous rocks. Also can be changed to metamorphic rock due to, we are going to see all the processes that affect the rock and it will be changed to metamorphic rock. We're going to be seeing all those processes. So are you following?
Yes, ma'am.
All right. And do you understand? You already know that, right?
Yes, ma'am.
All right. So your igneous rocks, just like I explained. Now, who is that person? This is my system, so I'm finding it difficult to. This is not my system. Sorry, I'm finding it difficult to operate it. I can't see who is talking. People should respect yourself. All right. It seems there's a chat. Let me see. Is there a question? Okay, you all drop your. All right. All right. It's okay. Thank you. So what generally happens is that I remember I said that the initial process of all these rocks is molten magma, which is it initially started from partial melting of pre-existing rocks, which is a partial melting of metamorphic rock. So how this form? The first thing that form is generally you have the compression, the compressional melting is the process whereby the mantle rock melts and form magma when it is moved from high pressure area to lower pressure area. It can form melting. Then you have a melting of rocks due to plates sinking to lower hotter layers due to high pressure. You can see here, remember your tectonic, your plate tectonics. You're going to be learning that where you have convergent belts, you have two plates coming together, and due to the density, one of the plates will be submerged beneath the other one. You have continental crust and oceanic crust. Okay, one will definitely go beneath when they meet. And when this one is pushed beneath, due to high temperature and high pressure in the mantle, melting of that rock will start, which will bring the molten magma to the surface. So I'm giving you instances of how we get molten magma. Or in the first one where you have the compressional melting, whereby it has to do with release of pressure and due to it's also tectonic activities where you have opening of the crust. These generally happen mainly within the oceanic ridge, around the oceanic ridge, where you have opening of crust, the divergent belt, where two plates are separated from each other. It creates a space that the magma can forces itself into the cracks up to the surface. So those are the two major processes of magma generation that forms igneous rocks. I just want you to have an understanding of where the magma is coming from. We know that the core of the earth is molten rock. So the magma generally comes from the core in this first place, where you have molten magma forces itself up to the surface, or in a case where pre-existing rocks are pushed down towards the mantle and then they generate heat and then they melt and come up again to the surface due to buoyancy to form rocks. Are we following?
Yes, ma'am.
So it means that rocks form from lava at the either at the earth surface. So there are two different things. I notice that students generally mix it up. When the magma get to the earth surface, and you are seeing it like this that is flowing on the earth surface, it is no longer called a magma. It is called a lava. Do you understand? But when it is still beneath the earth's surface and it has not erupted, it has not come to the surface, you can call it a magma. So it is a magma that will crystallize plutonic rock. Plutonic rocks are those ones that form under the earth's surface, while lava will form extrusive rocks, those ones that form on top of the earth's surface. Do you understand?
Yes, ma'am.
All right. So when magma, Prof is going to teach you because this is not I'm not supposed to teach you anything lava, magma. Even the next slide is still Prof home. But because she has not done it, I just put some here so that you can follow. But she's going to teach you everything proper. Just in case some of you don't have never heard of anything like this. I don't just want to jump into metamorphic without you having understanding of the igneous, because you need that to have good understanding. So you can see this one beneath, this one that is a rock that you can see different mineral with your eyes. She's going to teach you how to name rocks that you can see with your eye, those that you can see. She's going to teach you everything. So this one that you can see the mineral are those that form within the earth's surface. They had a lot of time in their hands to cool down and crystallize so that they form large crystals. But this upper one is an extrusive rocks. The magma that formed this one came to the surface. So it is no longer called magma, it is called lava because it has erupted up to the surface of the earth. So when this one at the top, whenever it crystallizes into very fine grained rock that you cannot identify the minerals with your naked eye. Okay, you will need a microscope for you to be able to identify the minerals. Why? Because they cooled down very fast. And because this rock cooled down very fast, the elements or the atoms that were in the magma did not have time to come together and bond to form large minerals. Okay, so they form very fine grained minerals. So this is an example of rocks. Prof is going to teach you. Okay, the rocks are generally igneous rocks are generally classified into three. Right, you have the darkest. If you notice it, they are called gabbro or basalt. You have andesites, which is medium. Then you have the acidic or um, 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 yes, you generally leave it at acidic so that you can understand the classification. They are, because they are called acidic because they have high silica content. Those are the ones that form the light colored rocks that you are seeing. Okay, so let me explain for you now. You can start from this point. You can see these ones are light colored compared to these dark ones. Okay, what happened is that this one above are the volcanic rocks. Volcanic rocks means that the magma came to the Earth's surface, so it is now called a lava. These upper ones formed from lava, crystallization of lava because it got to the Earth's surface, while the lower one formed beneath the Earth's surface from crystallization of magma. So because the lower one formed beneath the Earth's surface, the crystal grains are bigger, while these ones, the crystals are very small of the mineral. The rhyolite you are seeing here is the equivalent of granite. They are the same chemical, they are the same magma that formed this lower one, that formed this upper one. But because this lower one had time to crystallize, it formed fine grain. But this one at the top, it crystallized, sorry, the one at the top crystallized very fast, so it formed fine grain. While the one at the bottom, the granite, crystallized, took a long time to crystallize. So what happens? It forms coarse grained texture. The same thing with the intermediate one. The intermediate is either acidic or it's either andesitic or diorite. They are intermediate. For the andesite is the volcanic one, while the diorite is the plutonic equivalent of the andesite. Okay, you can see them; they look alike, but the crystal structure here, the crystal mineral grain here, are more visible than the mineral grain here. Okay, so they are generally of intermediate composition. The silica content is a little bit lower compared to this one, but a little bit higher compared to the basalt and the gabbro. The basalt and the gabbro are the same rock also. The gabbro is the plutonic, basalt is the volcanic. The same thing, just the environment of crystallization that is different. These one crystallize at the Earth's surface, these one crystallize beneath the Earth's surface. So she's going to also teach you types and textures of igneous rock. She's going to teach you aphanitic, which is a fine grain texture formed from rapid cooling. Then she's going to teach you phaneritic, which is a coarse grain texture formed from slow cooling. So I'm going to ask you a question now, and I want you to unmute yourself and answer. The aphanitic texture, that is the fine grain texture, will it form a plutonic rock or an extrusive rock? Let me hear.
Extrusive, ma'am.
Okay, extrusive rock will form fine grain, while the phaneritic will form, which rock forms phaneritic texture?
Intrusive.
Intrusive, good. So she's going to teach you all this. I just don't want us to jump into a metamorphic without me giving you an idea. So this is generally just with means. Phaneritic, you can see the grain texture here. Aphanitic, you cannot see it. There are other textures that we are not going to go into. You have cryptocrystalline and so on and so forth. But phaneritic generally means that the matrix in the grain is large enough for you to see with your naked eyes. While aphanitic, you can see it almost plain here, is a grain size that is small, that cannot be distinguished with the naked eye. But you can use a microscope to look at it, okay? So this is what an aphanitic rock looks like, okay? You can see it here. This is a rock. You can see the small picture attached. The one in cycle is a petrographic microscope. Is when you cut in section, you take it under the microscope and you look at it under the microscope so that you can see the grain sizes. You can see when you magnify it. In this case, the grain size, the rock has been magnified so that you can see it. But other than that, with your naked eye, you cannot make out the different grain, the different minerals. While in the phaneritic, you can see them. You can identify biotites, the black ones. You can identify feldspars, these ones that look like pinkish, okay? They're the potassium feldspars. Then you can identify the white one, which is the alkaline feldspars. Then if you look closely, there are those that are not white, they are not pink, they're more like gray color, okay? You can see them inside. Those are quartz. Okay, so this is the thin section. This is the petrographic microscope picture. This one that you can see here. So you can see here, you can see feldspars, you can see quartz, you can see biotite. The same thing here magnified so that you can see it very well compared to here. Okay, so the phaneretic cool down slowly, and you can see it, while phanetic cool down very fast, and you can't see it. So there are other textures. You have the porphyritic texture. Porphyritic texture is that when you have both the large grain and the small grain, you have both aphanitic and phaneritic texture in one rock. It's called porphyritic. You have the glassy texture. Okay, this is an example of what porphyritic is. You have the big grain sizes, and then you have the smaller grain sizes. That is porphyritic. So you have the glassy. You can see it. It's glassy. You can't make out the glassy is close to affinity. Okay. So we've done the rock cycle already. So we are starting metamorphic now. Our course is what? Metamorphic. So I am starting metamorphism now. Okay. So this part of the course focuses on rocks that were pre-existing but has undergone some changes due to temperature, pressure, or chemical active fluid. Okay, so the term metamorphism means the change to a rock. The main rock is called the parent rock. Okay, when the parent rock is changed from its original composition or texture to something new, you call that rock a metamorphic rock. It can be a sedimentary rock, any of the sedimentary rock, shale, or a or an igneous rock, basalt, gabbro. Any rock can undergo metamorphism. Okay, and the metamorphism is caused by some parameters called agents of metamorphism. So there are generally three agents of metamorphism. Okay, you have the heat, the pressure, and chemical active. Chemical active fluid are high temperature fluid. These are fluid that occur in 1,000 degrees Celsius or hundreds of degrees Celsius. Okay, they are generally fluid that were heated by magma or fluids that have circulated around magma, hot water that circulated around magma that is very hot. Okay, they are generally referred to as chemically active fluid or high temperature, any high temperature fluid that is above 800 degrees Celsius or even up to 400 degrees Celsius can alter the composition of a pre-existing rock so that it can metamorphose it. Okay, so there are, okay, let me go all over what I said again. I said metamorphism is the process or the change in a pre-existing parent rock. Okay, this change can be mineralogical, it can be structural, and it can be chemical. Do you understand? So if the change is mineralogical, it's also metamorphism. If the change is structural, it can be metamorphism. If the change is chemical due to this chemical active fluid I just described, it can also be called metamorphism. So any of these three, and the three major agents of metamorphism are heat, pressure, temperature. So metamorphism generally occur at very high temperature and pressure, okay, than weathering. We know weathering is high temperature, pressure affecting rock. But metamorphism requires higher temperature and pressure than the normal weathering. When the rock melts, when it has started melting, it is no longer considered as metamorphism. But the interval between it being a normal rock and it starting melting is where you have your metamorphism. Okay? It has not started melting, but it has started getting molten. But the melting is not full. Okay? That is the range of where metamorphism is. So when melting starts, it is an igneous process. It's no longer a metamorphic process. So that metamorphism encompasses all solid state changes that affect the fabric of a particular rock surface. So metamorphism can include, when I say that, it can be either mineralogical, structural, or chemical. It can include the growth of new minerals. When new minerals grow, that is restructuring occur in the rock, and then the crystal structures are changed in such a way that new minerals can grow. Due to temperature and pressure, it can be referred to as metamorphism. So some common characteristics of metamorphism uh, is the hardness of the rock can be changed. The texture of the rock can be changed. The foliation pattern, we are going to be seeing all this, okay, in the process of describing metamorphic rock. Number one, textural changes can occur. That's why I said new minerals can grow. Number two, the hardness of the rock will change. It generally becomes harder due to high temperature and pressure, okay? You will have shale or mudstone. Mudstone can be forced to form a shale, okay? Because it has undergone compactment due to high temperature and pressure, which means the rock has become hardened. Shale can go to phyllite. Phyllite can go to schist. And as the changes in temperature and pressure continue, the hardness of the rock increases. Okay? It gets harder due to higher temperature and pressure. The same thing with foliation. Most metamorphic rocks are foliated, but we have unfoliated metamorphic rocks. You're going to be seeing the different types of metamorphic rock when we look at classification of metamorphic rocks. They are generally classified into foliated and non-foliated. We're going to be seeing the example and how each type formed the foliation, what causes the foliation. We're going to be looking at that later. So the last thing that changes in metamorphism is the grade of metamorphism. The grade of metamorphism has to do with the first two parameters, which is the pressure and the temperature. They are what affects the grade of metamorphism. Okay? So a rock can be moved from a low grade metamorphic rocks where just minor changes has taken place. The minor changes due to temperature pressure, not high temperature, probably just 800 degrees, and then the pressure just about 5 bar or so. Minor low grade temperature to high grade metamorphism. So you have metamorphism moving from low grade metamorphism to high grade metamorphism, depending on how high the temperature is or how high the pressure that affected the rock is. Okay? So all this I'm describing is what can happen to a parent rock. Okay? The parent rock is the main rock that was pre-existing before metamorphism took place. So it can be any rock. The parent rock can be a sedimentary rock. It will undergo high temperature, pressure, or chemically active fluid to form a metamorphic rock. The parent rock can be an igneous rock. Any of those igneous rocks I showed you, the rhyolite, it could be granite, it could be andesite, it could be gabbro, whatever, it could be diorite. Any of those rocks can undergo high temperature, high pressure changes. And due to these high pressure, high temperature changes, this rock can be changed to metamorphic rock. Okay? Then last but not the least, a metamorphic rock can also be metamorphosed again.
Bro, I don't even think the place they told us to
Who
do
is this
class.
Saba, or what's his name?
I've seen the classroom now. They said
Babatunde?
that place is locked.
I wish this laptop is what I can operate. Let me just remove that fool from this class. So I'm saying that apart from the igneous rock and the sedimentary rock being changed to metamorphic rock, a pre-existing metamorphic rock can be changed to metamorphic rock again. Why? Probably the first metamorphism that took place is low-grade metamorphism. The rock can undergo another high temperature changes whereby it will be changed to high-grade metamorphic rock. Are we following, Eniola?
Yes, ma.
Do you understand what I'm saying?
Yes, ma.
No, if you don't understand, tell me because you're the one speaking for the class. If you don't understand, it means I have to repeat myself. But do you understand?
Yes, ma.
All right, so I can continue, right?
Yes, ma. You can continue.
All right, let me know when it's time. You said you have another class. So you understand that what metamorphism is right now, right?
Yes, ma.
Is the mineralogical or structural changes of a pre-existing parent rock, right? You already understand that to a new rock type. Do you understand that? And there are three agents of metamorphism. It can be heat, it can be pressure, it can be chemically active fluid. You understand that, right?
Yes, ma.
All right, so let's go forward.
Sorry,
So,
ma. The class starts now.
Oh, your class is starting now?
Yes, ma. This past 12. Sorry, ma.
All right, so we'll meet next Friday, please. Or if your class rep can find a time before Friday so that we can do two classes. If you can finish on time, this course is a little bit bulky. My section is bulky.
Okay, ma.
All right, so you can talk to your class rep because he's not in the class now. That if you can find another time apart from Friday, or you can make it Friday. After this next class, are you free?
No, ma. We have classes on Monday too.
And tell him to fix another time so that we can finish on time. Okay. Or he can extend my time to 2 hours.
Okay, ma.
All right, so we'll meet next week, right?
Yes, ma. Thank you, ma.
All right, you're welcome.